Okay, we're going to discuss the ionic product of water. Okay, so I suppose ions are required for electric current to flow, and in theory pure water shouldn't contain any ions, but we have seen through experimentation, that water is capable of carrying a tiny electric current. Okay, so there is ions present in some way. That is because water dissociates, okay, to produce ions. Okay, so water splits into its two different elements that we know. Okay, so we know that water obviously is H2O, and that dissociates into H plus and OH minus. Now, that equation is used in questions, alright, but we do know that it isn't 100% accurate, because these H plus ions don't exist in isolation. They don't really exist by themselves. So a more accurate way of representing this would be that it's 2H2O. I'll give you H3O plus plus OH minus. Okay, so that's a more accurate way of representing it. Both ways are used in questions. Okay, so even though this one on the left here isn't 100% accurate, it is used in questions. Now, we in the chapter for equilibrium, we saw that the equilibrium constant, Kc, alright, is the concentration of your products over your concentration of your reactants. Okay, so that would mean let's just take the left hand side here as an example, that concentration of our products, so that Kc would be equal to that. Okay, and on the right hand side we would have a situation where it would be Kc is equal to H3O plus OH minus, square brackets are important, and this would be H2O squared, okay, because of that too. Alright, so they would be our equilibrium constants for them reactions. Now, we can rearrange this in order to get the ionic product of water. Okay, and the reason why we can rearrange it is that the concentration of water doesn't really alter. Okay, it doesn't really change, unlike where you could have maybe 1 molar or 2 molar or 0.1 molar concentration hydrochloric acid or sodium hydroxide or whatever it is. Okay, you can have different concentrations of it. The concentration of water doesn't really change. Okay, or the changes that can occur in it are so small that in chemistry they're almost considered to be a constant. Okay, so for that reason we can rearrange it to say that that we can have constants on one side of our equation and things that change on the other. So on the left hand side we can have Kc multiplied by H2O would give us H plus H minus. Alright, and then the ionic product of water is the constant is just substituted in for this term. So Kc H2O is known as Kw. Okay, so if you say Kw anywhere, that's what it's representing. Okay, so Kw is equal to H plus OH minus. Alright, and same thing happens on this side, that Kw can be H3O plus. So both terms are correct. Both terms are used in questions and so on. Okay. Yeah. All right. So that's our ionic product of water, and that ionic product of water, Kw. Okay, which is that is equal to 1 by 10 to the minus 14. Alright, so that is the figure that we have for it. When water is neutral, okay, so pH of 7, alright, the concentration of H plus and OH minus are equal. Right, so if you have an equal amount of H plus and OH minus, you have a pH of 7, you have a neutral solution. Okay, we know water is usually pH of 7, okay, or is neutral. That Kw figure is temperature dependent, okay, so it changes with temperature. Okay, so the value of that will increase as temperature increases. This dissociation, okay, whichever one you want to take, is an endothermic reaction, and the concentration of H plus and OH minus at 25 degrees Celsius can be calculated. Okay, that's assuming that we have a neutral solution. Okay, if we have a neutral solution, we have the same amount of H plus and OH minus. Okay, and the fact that we know it's at 25 degrees is at room temperature would support that. If it had a different temperature, we'd be looking at something slightly differently. Okay, but when we're at room temperature, water is going to be neutral. Okay, or at a pH of 7 usually. Okay, and in even cert questions, that's what they go with as well. Okay, so if we have that Kw okay, so we know that in this example that the concentration of H plus and the concentration of OH minus are going to be the same. Okay, so we could say that Kw would be the concentration of H plus squared. Okay, if these two figures are the same, all right, it's going to be it'll be the same thing as squaring, all right, which would be equal to 1 by 10 to the minus 14. So to find your concentration of H plus, we'd have the square root of 1 by 10 to the minus 14, which would be 1 by 10 to the minus 7. Okay, you can work that out by your in your head as well, and that's what's needed, I suppose. If you want to get to 1 by 10 to the minus 14, if you multiply two numbers together, that's if they're in equal amounts, that is the answer that you would get. Okay, because that also shows if that's your concentration of H plus, if you want to multiply something to get 1 by 10 to the minus 14, that means that OH minus is also 1 by 10 to the minus 7. Okay,